Okay, much of what you're going to be doing in Calc, certainly Calc 1 or high school calculus course, is dealing with finding derivatives. And what the heck is a derivative? Uh, a derivative is the function that produces instantaneous velocity. Sometimes it is said that the derivative is instantaneous velocity. Well, it can't be that because sometimes the derivative is, say, 2x squared. Well, 2x squared isn't a number, it's a function. Then you have to put in an x value at one given x value, and that will give you instantaneous velocity. If you plug in a different x value, it'll give you a different. So a derivative, a working definition, I did not look this up in like the standard Stanford Math Dictionary or anything, but essentially the derivative is the function that produces instantaneous velocity at a given x or t value. And one way to think about it, once you've plugged in a value to that function, it produces the slope of the tangent line, also called instantaneous velocity. And here are some important notations. First of all, anytime you see a d by itself over dx, or it could be a different variable than x, that is essentially the command. It is commanding you to take the derivative. It's not telling you what the derivative is. This phrase, this expression, is the command to take the derivative. If you're telling me you found the derivative, let me erase all this stuff now. If you're telling me you found the derivative, you would use this notation. This notation says the derivative is, the derivative is, the derivative is. And there might be other ways to describe it, but these are the most common ways that I have found that you will see when you want to know what the derivative function is. This would be a way to write it. But this right here is the command to take the derivative. The derivative means something is differentiable, but differentiability, I just botched that word, and continuity are kind of related. And this is what I mean. So if you've got a continuous function, continuity, continuous, at any point, at any given, whether it's here or here or here or here or here, you look at the graph, there's a slope, there's a slope, there's a slope, there's a slope. Continuous graphs, you can always find the derivative. So differentiability and continuity go hand in hand. So differentiability implies continuity. If f of x is differentiable at a given c value, when x is equal to c, I should say, then that means f of x is continuous at that x is equal to c. So there you have it. And I think I might have shown it over here. Oh, that's going to be a different video. All right. So what have we learned in this video? The derivative is the function that produces, it's a function that produces instantaneous velocity at a given x value, and there's the important notation to know. And by the way, if you're not using that notation in a college course or even high school course, you should be losing a lot of points, because this notation tells the reader what the heck you're talking about. If you just say, give an answer that says 3, what does 3 mean? Is 3 a height? Is 3 a slope? Is 3 what is 3? The only way the reader, meaning the people grading your test or your paper, will know that is if you're using proper notation. All right, that's it for this one.